you should have out a piece of paper, and yours doesn't need to look exactly like this, or you can print out a copy of this if you would like, and then we'll have a second part that's down here. So we're going to start here with slope notes, and we're going to start with rate of change, because that's where we started at. In the very beginning, when we started doing this, we started talking about slope as a rate of change. And rate of change, how one variable changes in relation to another variable. Okay? So let's do some examples here. Okay? Oh, before we do the example, how about we do the change of the dependent variable. And remember how we talked about that's usually the y over the change and the independent. Oops, that was weird. Can't spell today. That's really all spelled wrong, isn't it? Let's try it again. Independent. That looks better. X. Okay. So we're going to change the color up a little bit. We talked about price per, remember the word per, pound. Okay, we've talked about miles per hour. We've talked about cost per month, or cost per lots of things. A lot of times, if you look at the bottom on the last two that we've taught that I just wrote down, it's a time period. I don't know, so water used per minute. A lot of them have where the time is the independent variable. We have time as the independent variable. Now, two things that we have with slope is always the direction and the steepness when we talk about things. Direction, if I look at this, it's the direction on this is increasing. Okay, and when it's increasing, we're talking about it being a positive slope. When it goes this way, it is decreasing. And it has a negative slope. That's an N, by the way. Then we have, well, that wasn't a very good horizontal. There we go. Looks a little bit horizontal. And when it's horizontal, remember that it has a slope of 0. That is a horrible horizontal line. Oops, I didn't mean to do that. Let's see if I can make a better horizontal line. That's a little bit better. Then, last but not least, nope, that's the same color I used a minute ago. We have a vertical line, and that's a horrible vertical line also. And when it's a vertical line, then it has an undefined slope. Now, if we're talking about the steepness of a line, okay, if we're talking about a steepness of the line, okay, this right here, this is not steep. Okay, that's not steep. Okay, this is steeper. And then, sorry, this right here is very steep. So if we're looking at this, not steep is going to be a smaller number. Steeper is going to be a little bit bigger, and very steep is going to be a higher number. Okay? So, the next thing I'm going to look at is the top up here. And we have an equation. And when we first started talking about this, we said y equals mx plus b. When we talk about this, the m stands for the slope. Okay? The slope is always the coefficient of x. Always the coefficient of x. Then we have the b, and that is the y-intercept. Okay? And when we talk about that, it's the constant. The number that stands alone, it's the constant. So if I was given the equation y equals 1/2 x minus 3, my slope is the 1/2, my y-intercept is the -3. But remember, when we talk about y-intercept, we write it as a point, 0, -3. Okay, then we talked about it being in a table. And when we talked about it being in a table, we looked at what it goes up by. So first things first, I'm going to look at what it goes up by on the y's, or what it goes down by. In this case, it's going up 1, up 1, up 1. Over here, it's going up 2, and up 2. Remember, they have to go the same direction. So we'll do the change in y over the change in x. So the change in y is 1. The change in x is 2. Then when we do the next one, I'm going to change the color on it. We look at y, and it's going down by 3, goes down by 3, and down by 3. Up here, it goes up by 4, up by 4, up by 4. So when I do the change in y over the change in x, I look at the change in y, and that's -3. I look at the change in y, and that was 4. Okay? Remember, I'm going to write that in a different color. Remember, y always goes on top. And I should say the change in y always goes on top. Okay? So then I guess I should have talked about this one first. I've kind of already talked about it. Okay, it's the change in y over the change in x. And so that's the change, really? Change in y over the change in x. Now, sometimes you'll hear this as being said, m equals rise over run, which is still the change in y over the change in x. When we talk about it as a formula, though, we say y2 minus y1 over x2 minus x1. So we're going to do that now. We're going to look at a couple of points. So let's see. I'm going to pick the point 0, 4 and the point 6, 12. And when we talk about this, right here, these are my y values. So this is my change in y. And these are my x values. So these two would be my change in x. So I have my slope. y2 minus y1 over x2 minus x1. So when I do this problem, I'm going to subtract my y values. Remember, the negative, or the subtraction sign, is already there. So I'm going to subtract my y values. 12 minus 4. I'm going to subtract my x values. My x values, because I used 12 first, I need to use 6 first. When I subtract these, I get 8 over 6, which simplifies to 4 thirds. Okay, you always have to simplify. Now, let's pick another point. I'm going to use blue. What if I had the point -2, 7, and the point 2, -1? So I do the same thing when I do this. I'm still doing y2 minus y1 over x2 minus x1. I don't have as much space, so I'm going to come and write it over here. Okay, I still have subtraction signs. So my y values are here. So this is my change in y. So I take -1 minus 7. And then these are my change in x. So I take, because I use -1 first, I have to use 2 first here. And then that's a -2, so I have to write a -2. So when I do this problem, on the top, I'm going to come out with -8. On bottom, these two negatives, boys and girls, changes to a positive. So I'm going to have 2 plus 2, which is 4. So the slope I get from this is -2. Okay. Awesome. So now we're going to come down to this part right here. Okay. We have types of slope. So we have a positive slope. Let's, really? Positive slope. Let's say if I have a positive slope, what kind of line it is? It's a diagonal line. Okay? It's going to go this direction. Okay? This equation is going to have an x and a y in it. It won't just have one of the two. It has to have an x or a y in it. Oh, why did I do that? I want this color. So y equals 2x. Y equals x minus 3. Y equals 1/2 x. Y equals 4x plus 5. Okay, those are examples of a positive slope. Now, if I was to have a negative slope, it's still a diagonal line. It's just going to go this direction. It also will have x and y in it. It'll be things like y equals negative x. Y equals negative 3x plus 2. Y equals negative 1/3 x minus 7. Or y equals 5 minus 2x. Those all have negatives in front of the x. Okay. So next, if I have a 0 slope, my line is going to be horizontal. It's going to be this way. Oh, that's much better. Okay. This is going to have y only. So, y equals 5. Y equals negative 3. Y equals 0. Y equals 1/2. All points have the same y. Okay, and then last but not least, we're going to make it this one. And this is if we have an undefined slope. And this is going to be a vertical line. And this will be x only. So x equals 4, x equals 0, x equals negative 1/2, x equals negative 6. Okay? All points have the same x. This is not a function. Okay? There we go. I hope that helps.